现在可能没有人。没有人。Oh, hi team. We have 4. We have 4 now. I actually don't have anything specifically to say today. Hi. Okay, so just a quick announcement. Well, Abhi said there's gonna be a closed book. There's gonna be a closed book exam. So, okay, just forget about. I'm good. Just forget about what I have been saying, like, over this week. It's gonna be a closed book. Then a good thing might be, then the difficulty should be the same as the previous one. But still, I guess to study these lectures well, it would be really helpful if you can find the interconnection between different materials we have gone through in the lecture. And second thing, you might receive the announcement that Dr. Wang has posted a revised question which we have gone through yesterday. So yeah, it's about this one. Do you know how much? Should be 50-50 as usual, because there are 4 lectures from Dr. Wang, then 4 lectures from Abhi, so that should be equally distributed. So it's about this one. So as we discussed, if this is a question, then both C and D are correct, but she changed the D to increases, so to make that correct answer C. But just from the view of study questions, we know if this is a question, both descriptions of C and D are correct. That's how we said yesterday, right? Other than that, I will definitely, do a summary on Saturday once we have done everything. Once we have done everything, I kind of have a feeling that you guys should still have questions on Dr. Wang's part, right? Especially second, third, and fourth lectures. Just say something about today's lecture. I think that's very straightforward, and since the title said is 27, 28, so I guess that's all for this quarter. So we only have this till the end. Then I'm not sure now if Abhi has those definition questions now, because as he mentioned, we're gonna have the closed book, which to say he might still have some definition questions, but I don't know how this is gonna be delivered. But his part is really straightforward. For today's lecture, anyone can tell me where he stopped at today? Because I just because I fall asleep at the second half. I only catch up somewhere here. Okay, so that's not far away from where I stopped. Which means tomorrow we only have 7 slides to go. You might just have a really like a Q&A session after that for the entire final exam. Yeah, I know. But this is somewhere from the previous lecture. I actually had gone through this Monday, but I can start with this too. Well, this is just a idea of drug delivery. So okay, so but it's a clotting cascade tomorrow. Yes. Still, I mean, it just depends on the difficulty of his test question. This may be, well, if he still has the definition question, this may be a cool idea that you actually, at least you should know, like the philosophy, the theory behind this, right? So this is like the idea when we talk about like pharmacophore. It's just not a definition, it's like an idea of drug design. So this is not a strict definition or theory, but is actually an idea, like how we deliver the drug or those like toxic drug into a specific site, which here is the well, you mentioned like cancer tumor cell. We have gone through this. Well, I guess if there is a MCQ that asks you, given you guys a drug name, then ask you where is this from, I guess that kind of question should be free. This one, yeah, together with this one, this is a T cell immune response. So similar to antibody, the T cell receptor also have this hypervariable loop. Yeah, what kind of question you might ask on this? I don't know. Maybe ask you like, we can find hypervariable loop in which construct. So far, we can find that from IgG. We can find from Fab domain and T cell receptor, and also the FC Fab. Oh, sorry, it's the SC. What do you call that? SC something, but not FC, because FC domain does not have the hypervariable loop. Well, these are gonna be really straightforward, easy ones, but the idea is actually combine different materials, like combine the knowledge of those points from different lecture slides. Cytotoxicity. So, oh yeah, mentioned something about this, but this is also quite straightforward. If both binding, gonna say okay, this is good, and if one will interact one, either block this side or block this side. He had gone through this signaling cascade in the afternoon. What should I suggest? Definitely won't require you to memorize this pathway, but ideally, similar idea is that what can cause the immunosuppression, or what can cause what can silence T cell activation. Then you should know from this pathway, like here, this drug. Also, I guess this one also can be included, because they just forbid the T cell to be activated by this, by blocking this recognition. This one I heard people asking about this. But I don't think we can have any question on it. Just like a cool idea. Well, what I remember from this slide is just this is like a personalized stuff and really expensive, so it won't be applied for all the patients. So this, okay, I cannot pronounce this well, but it just shows an entire lineage of the blood cells. I know we kind of gone through this for detail in this slide, in this video. That is neutrophil. Okay. Well, one of the core thing or core case study here might be something related to this. I mean, in this lecture, because this is the cause for the immunocompromise, which is having a really low level of the neutrophils. And definitely we watch this video, like how this chasing the bacterial in between those red blood cells. So this, I guess these two slides are important for today's lecture. I don't know if we should memorize all these names, although they're the drug discussed in the lecture, and we were supposed to remember this from his lecture. So the difference here is all the three are expressed in E. coli. So what's happening in E. coli and in mammalian cells, the difference between these is like from E. coli you won't get the glycosylation, so there's no post-translational modification. For most of these membrane proteins or something like that, the glycosylation is one of the really important class of the modification of the post-translational modification. So you should know like all the three are without the glycosylation, and in mammalian cells they are the peptides expressed here in mammalian cells can be glycosylated. So that's why in my research, when I study those viral membrane protein or those spike proteins, we can only express that in the human cells or in the mammalian cells. But for other proteins, when usually people for like either crystallography or EM, they can either express in E. coli cells, which is the common one, or insect cells, which is also very easy to grow. But to study those viral membrane protein, you have to express that in mammalian cells because you want to retain their glycosylation. This graph, I guess the same for this PAG modified drug. You're gonna need one injection. It can have a prolonged level or half-life, because it just prevent renal clearance. Okay, so this is the point that you might need to understand, because this drug could be cleared renally or by neutrophils, but we wanted all of them to be cleared by neutrophils. So to increase that level, we're kind of trying to reduce the renal clearance of this drug. So that's why they have a PAG conjugated or PAG linked. And this one thing that you should bear in mind, that you should know, is why this works is that the bacterial membranes are more negatively charged. So these peptides are tend to be cationic. So which means this kind of interaction is mostly electron statics. And okay, the hemostasis. What is hemostasis? 1 second. Oh, okay. So if we have the definition question, this might be something that you should know, and it's actually quite straightforward, but also quite important idea. Okay, okay, so this is hemostasis. Okay, I almost messed up with homeostasis. So maybe you can say, okay, heme is like something with the blood. Then you're gonna know is like the maintenance, the balance. When if it's bleeding, you have the balance to stop that bleeding with like coagulation or anti coagulation. So it's like okay, or I mean, to memorize these two words should be easier, or you can just say like a balance between bleeding and clotting, right? I can accept both answers, but your way. So another thing that I can imagine is that, say about clotting, about bleeding and clotting, we're gonna discuss something about platelet. Then if I say something about platelet and anti-inflammation drugs or molecule, that what will come to your mind? I mean, could you remember something we have gone through? We talk about 3 molecules that were in the anti-inflammatory um, response and related to platelet. So what I actually refer to is, say, yep. Yeah, actually what I refer to is like this 3. But yeah, you're right. Also, with all aspirin and all this SAIDs, so one thing is that because these stuff are talking about same thing, similar stuff on platelet, just make sure that you know there are we have discussed these 2 lectures, but somehow don't mess it up if it's in the MCQ. But if the MCQ actually connect both points from these 2 lectures, you should also be clear that we have gone through this twice. One is from the lipid stuff, then one is from the hemostasis. That is all for today. So do you think you guys still have do you guys still have like more questions on Dr. Wang's part? Because Dr. Wang asked me early today, say like, how's this review sessions going, and will I have another review session over the weekend? I said yes. So if you have more questions on her part, I might shift the focus to her part for our final review, which I'm thinking to have that on Saturday sometime. Like maybe afternoon, or maybe like the same schedule, but I'm gonna have one like an overall review on all those stuff covered in this exam. So your call. If you think that her part is still you have more questions on her part, then I will just shift the focus on her part again. Yeah, well, I think that's all for today, because we only have this few slides. And actually, I have bought a new camera, so maybe tomorrow or Saturday. Okay, yeah, ask question, please, yeah. Or maybe tomorrow Saturday, um, I can just like write it down something I was while I am speaking, so that you can see what I have written down for summary. How does okay? Give me one. Wait, that's from her part. That's from. Oh, sorry. Where is? Oh, okay, here. Let me see. Well, so here we can infer that this is an inhibitor of OAT1 and OAT3, so which reduce the renal clearance of those drugs using these two transporter to get into the kidney. Oh yes. Oh yeah. Just use it. Don't worry. Yep. Oh, don't worry. Sorry. So these two let's see, this is dose dependent. So for sure, when you have the OAT1, OAT3 inhibitor, these drugs will have lower renal clearance. So you should have more of these drugs in the blood, right? Oh, okay. So I get the point. So 1 second. So this nephrotoxicity is actually the is a toxic effect on the kidney cell. So we know so for these two drugs, we know the renal clearance is way larger than GFR, which means most of them are from the secretion from the blood to the lumen through the kidney cell. Then we know the speed of this compared to the speed in the lumen. I guess she had an example which discussed like the speed of something in the lumen is really slow. That's why it causes a higher drug concentration or something. I mean something before this, but here because of this difference, these drugs are actually yeah, but this is not PGP, is OAT1, OAT3. So you have this clearance which is very large. So with OAT1 and OAT3 working like functioning, then you got most of the drug accumulated in the kidney cells, which then this toxicity is dose dependent, so it causes like it has this toxic effect on the kidney cell, which is this one. So if you have the OAT1, OAT3 inhibitor, it will inhibit some OAT1, OAT3 transporter, so you will have a slow uptake rate from the blood into the kidney cell. So this will kind of balance the uptake and the efflux. This will balance kind of from the blood into the kidney cell and the kidney to the lumen. So it won't have this it won't accumulate in the kidney cells and have this toxicity effect. But before this, we actually compare something about the reabsorption rate. Oh, I mean the yeah. Oh, is here. So that's like a driving force of passive reabsorption, which is also due to the speed. So that's the reason. So if it's here, then you can see that. Oh, well, you're 99% right. Just because PGP is efflux. PGP is from the cell to the lumen. So we kind of discussed something similar here. So the driving force of the reabsorption is here actually, like in the lumen, the speed is very slow. So when the speed is slow, you kind of concentrate the drugs, then the passive reabsorption will get your drug back to the cell. But it's really not that interesting when I TA this part than last part. I found like the materials covered in midterm 3 are more interesting. and just like kind of from my spec of view. I am not that interested in this part. Yeah. 103, 1-3. So here, this transporter is kind of equivalent to PGP, right? Okay, yeah, well, and there is PGP, but PGP is for organic cation. So this one is for organic anion. Yeah, well, I will make sure there won't be any really tricky question or really unclear question. Yes. $500,000 is 500. Yeah. So 500,000 should be equal to 500 AU stigatonet unit. So in the microscope, under microscope, well, we'll say that in the from like microscopic view, that's equal to gram per mole. It's like water is 18 grams per mole, but it's like the atomic mass is 18, which is 18 AU. No, sorry, not the atomic mass, it's the molecular mass is 18 AU. Then for protein, because it's large and usually, so that's why we use Dalton or kilodalton. So on average, one amino acid is about 100 to 110 Dalton. Okay. Or if you have any like a general biology question that you want to ask, you can also ask, or some question from other class that you think I should know. You can also ask, or you can always Google that if it's like quite simple ones. Yes. You mean the animals or the TV channel? Of course. Wait, there's a emoji like this? Uh-huh. Okay, see you guys tomorrow. Okay, let me see how this works. Let me do a test run. What about this? I'll see you. Bye. Oh, this makes me more like a real YouTuber. Okay, it's like these days at home, I'm really interested in dealing with this like streaming software. But yeah, see ya. Bye. Oh, cool. Yeah, thanks. But it's a long way to go to get 10,000 subscription. I mean, it's like I watch other YouTubers. They receive those like a medal. No, not a medal, but it's like plate saying that that's like 10K followers or like 100K subscription. Wow, that's a really long way to go. Unless, well, I'm thinking that I can live streaming on like having food, street food or whatever stuff. Never mind. Well, yeah, we'll just see you tomorrow for our last lecture of this quarter. Okay, bye. Thank you guys.